Cool, let's get started. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google based in London.
And I'm Chris, and I'm a software engineer, also based in London at Google.
So today we're going to be talking about running .NET containers on Google Cloud. And one thing that we didn't mention, we actually have a Google Home. And what we're going to do is we're going to get Google Home.
Which is this thing here.
It's Google Home Mini. And we're going to be getting Google Home Mini talk to a .NET container running on Google Cloud. We didn't mention this in the title abstract because I was talking to Chris about what we should do about our talk. And then he said, why don't we just use Google Home? And I'm like, do you know how it works? He's like, well, I don't know, but we'll figure it out.
We can work it out, and we did.
And he did, yes. So that's kind of like the little surprise that we have. So the agenda of the talk is that, first of all, I'm curious, who is here running any kind of service in the cloud today, in any cloud? Okay, a few people. And who is running on Google Cloud? Google people, yes. Yeah, so that's why I wanted to do a little bit of introduction of what is Google Cloud, because whenever I talk about Google Cloud, people ask me, is it Gmail, is it Google Drive, or what is it? So we just want to do a little bit of introduction.
Did people know that Google had a cloud?
Who knew it before?
Who knew Google had a cloud?
Okay, so people knew.
That's more than half. That was better than the last time I asked.
Yeah, because last time I was at this conference, when I asked, no one knew. So at least this time people know, and hopefully next year people will be using Google Cloud.
And did you know you can run C# code on Google Cloud? Yeah? Oh,
right.
fewer. Okay, that's not surprising.
Cool. And then once we do the intro, we're going to be talking about running .NET containers on Google Cloud, so that's the point of the talk. When it comes to running .NET containers on Google Cloud, you have two choices, App Engine Flex and Kubernetes Engine. So we'll talk about both and what the differences are and things like that.
And then we're going to move away from the compute side of it and talk a bit about the services. And we're going to demonstrate the Vision API. I don't know if you were in Scott Guthrie's keynote talk this morning. So we're going to demonstrate a Vision API, much like he did, but a slightly different aspect of Vision APIs. And obviously, Google's Vision API, not Microsoft's. And looking a bit at BigQuery as well, and demonstrating a bit of BigQuery. And then we will finish by looking at maintaining your app and looking at the Stackdriver suite of sort of debugging, monitoring tools. And we're hoping to demonstrate tracing, error reporting, and logging. We'll see if we get time and it all works.
Yeah, the idea with Stackdriver is that it's a central place to do all your logging, debugging, tracing. And for me, the debugging part is really, really important because you can put a breakpoint in production, and then it gets hit, and then it gives you a snapshot, and then your service still runs, so you don't have to stop anything.
But sadly, Mete, we can't demonstrate that, tragically. I tried to get it all going yesterday, but due to embarrassing technical reasons, we can't show that today.
Okay, but we will be crashing our app, and then we'll see the error reporting there, so at least we can crash our app, right?
I hope so. Yes.
Okay.
Hopefully not crashing it too much, but we'll see.
Just once so that we can show it to people, right? All right, so let's get started with the introduction. What is Google Cloud? Well, it's a collection of services for your application, for you to build your applications. So in terms of services, we have compute, so that's how you deploy your application. We have compute engine, which is what virtual machines are called in Google Cloud. So you can have a Windows server, you can have a Linux server with all these different configurations and operating systems. And then once you have it, it's yours and you can do whatever you want. There's App Engine, which is kind of like app services in Azure. There's Kubernetes Engine for running containers in production and get that managed by Kubernetes. There's Cloud Functions, which is kind of like Azure Functions, but in Google Cloud. There's a container registry to store your containers, and there's a container builder to build your containers. I won't go through these one by one, but basically for storage, there's SQL and NoSQL databases. One thing to point out is Cloud Spanner. Cloud Spanner, it's a SQL database that scales horizontally, kind of like Cosmos DB. For networking, you can set up all sorts of networking things like load balancers and private networks and peering and VPN, things like that. There's big data that Google is known for. So there's BigQuery that we're going to show you. It's a data warehousing solution, fully managed. There's Dataflow for processing data in the cloud. There's Dataproc for running Hadoop and Spark in Google Cloud. What else do we have? We have machine learning. So we have lots of machine learning APIs, such as Vision API that we're going to demo, Speech API, Translation API. These are basically pre-built models that we have, and we are just exposing it to you with an API call. And then there's also cloud machine learning. So if you want to build your own models, there's an open source project called TensorFlow. And we make building TensorFlow models easy and scalable with cloud machine learning. So you can use that to train your models in a scalable way. And you can also use it to to serve your model. So it gives you a way to basically serve your trained models. And then there's things like identity and security, and then there's more like management tools with Stackdriver that we'll show you, and then more developer tools like with SDKs, and we have IDE plugins and PowerShell commandlets and all that kind of stuff. So it's a whole platform to do pretty much whatever you want. Now, in terms of deploying your code, when it comes to deploying your code to Google Cloud and in any cloud in general, first, there's this spectrum, right? There's this spectrum of customizable versus managed. So the more managed things are, they usually are less customizable and vice versa. In terms of highly customizable, we have Compute Engine. So if you want to get a virtual machine and you want to define what kind of CPU it should have, if you want to define what kind of memory it should have, what kind of operating it should have. So once you define those, you can get a Compute Engine with Windows or Linux, and you can install whatever you want. So it's highly customizable, but at the same time, you're fully responsible of it, right? So there's no management of it. So you're fully in charge of it. If you install something on top of it, you need to maintain it. If there's a new version, you need to upgrade that. So it's yours to keep. Now, on the other, also we have something called Cloud Launcher. So Cloud Launcher is kind of like a marketplace for deploying solutions to Google Cloud. So for example, we have something called ASP.NET solution, where it deploys Windows Server, ASP.NET, IIS, and SQL Server on Compute Engine with one click. And I'm going to show you an example of that shortly. On the other side of the spectrum, we have Cloud Functions. So you've seen these earlier with Azure Functions, but it's basically the same kind of functionality where you just define a function and you deploy it, and Google manages the function for you. So you are not exposed to any virtual machines or any kind of containers or anything like that. It's just a function that you define what the input is, what the output is, and how it gets triggered, and then it's just maintained for you. The only difference here is that we only support Node.js right now, but we want to support more languages going forward. And then somewhere in the middle, we have App Engine. The idea of App Engine is that instead of defining a function, you're defining an application. And this application can have multiple services. So it can have a front end, it can have a back end, and they can talk to each other. But the idea is the same. You define your application and you deploy it. And under the covers, it runs on virtual machines. But you're not really exposed to those virtual machines. And you don't have to worry about them because it's managed by App Engine for you. And then sometimes you need more control. You need to be able to define your containers. You need to be able to define your container cluster and get the container cluster managed by Kubernetes. So for those kind of use cases, we have something called Kubernetes Engine, which used to be called Container Engine up until recently, but we renamed it to Kubernetes Engine recently. So the idea with Kubernetes Engine is that we give you a Kubernetes cluster with one command. You have a master that's managed by Google. And then you have the nodes where you can schedule the containers. And then you can resize your cluster. You can add more nodes and things like that. And we'll show you some examples of this as well. And then we have Container Builder to build containers in the cloud. And we have Container Registry, where you can store your containers for your project. And they can be private and public, depending on what you want to do. So that's kind of like the spectrum that we have. So today, we're going to be focusing mostly on Kubernetes Engine. That's what our demo is based on. But I just want to let you know that there's other options as well.
And just a quick word about Google's infrastructure. So Google is quite well known as being one of the leaders in the quality and reliability of its infrastructure. And the good news is that if you run on Google Cloud, you are running on that infrastructure. And that's an important point to make. You're not running on some kind of alternative infrastructure which is run separate from Google's own products. You are running on exactly the same, probably not the exact same actual CPUs, but you're running in the same data centers, using the same network infrastructure, and you've got the same sort of teams of engineers who are maintaining and are on call for making sure that everything runs as it should. And on a personal note, a few years ago, I used to work on one of these teams that was on call. I was on call for the Android Play Store. And I can assure you that there really are teams of highly dedicated engineers working 24 hours a day, 360 days, 300 and however many days there are in a year, making sure that everything functions as it should, and if it does start to go wrong, they fix it straight away. And we have extremely good monitoring tools, so most of the time you'll never know anything was even starting to go wrong. It'll be fixed before you know it. This is just an impressive looking map of some of Google's networking infrastructure. Google does own fiber globally, and these dots are all data centers or points of presence or edge cache positions, and you use all this. So for example, if you use Google's CDN service, your files or whatever it is will be cached in all these locations globally to be as close to the user as possible. And Google works hard to make sure that traffic from the internet gets onto Google's networks as quickly as possible because we know our networks are good quality. So users globally get routed onto our networks and then routed to wherever your services are being provided from.
Cool.
Right, so we're now going to look at some specific compute infrastructure now. So if you are an ASP.NET Classic developer, then you're running on Windows, and you can use Compute Engine to deploy your ASP.NET applications onto what are essentially, which are VMs. So this is as Mete was saying earlier, this is an unmanaged product. So you're responsible for making sure all your software's up to date and you've got the right number of VMs and they've got enough memory and all this kind of stuff. But it does let you fairly easily deploy ASP.NET applications. And you use it much like you'd use any VM anywhere. They're pretty bulk standard VMs. Are you going to demo that now, or?
Yeah, let's do that. Let me just show you how to get a Windows server quickly. So here I am in Google Cloud Console. And on here we have all the different products on Google Cloud that we'll go through later. But what I want to show you right now is Cloud Launcher. This is a marketplace for different solutions on Google Cloud. And one of them is called ASP.NET Framework. So this solution will get you a Windows Server, an IIS, SQL Express, and ASP.NET Framework installed on Compute Engine. So if you want to get one of these, what you can do is you can say launch on Compute Engine and make this a little bit bigger. So let's give this a name, ASP.NET NDC London. Then you can choose your zone. So since we are in Europe, let's just choose Europe West. And then machine type, you can fully customize it. So you can say, I want cores from 1 to 96. And every time I look at this, it increases. Last time it was 64, now it's 96. So let's just go with something like 6 cores maybe. And then memory, you can choose whatever you want, up to 34, 39 gigs.
But that goes higher if you're using more CPUs.
Yep. Or you can also choose one of the pre-configured ones. So if you want to get a small instance, you can choose that. So let's just choose one of those. In terms of Windows servers, we support 2008, 2012, or 2016. So let's choose the latest one. And then we can have persistent disk or SSDs. And you can specify the size here. And then you can also define the firewall rules, like so HTTP, HTTPS, web deploy, and RDP. So I'll just keep those as default and hit deploy. And within a minute or two, we'll have a Windows server running. And then you can use Visual Studio to deploy your application there. All right, so that's all it takes to get a Windows application for your traditional .NET application.
But of course, the world is moving to containers. And so if you're using ASP.NET Core and you have a containerized deployment you want to do, then App Engine Flex and Kubernetes Engine are the two ways to do it. As Mete has already said, Kubernetes Engine allows a bit more control. App Engine is sort of click and go and auto-scaling and all that good stuff.
Yep. And we also have some tools and libraries that you might need.
Yeah, so if you need Microsoft SQL Server, then much like Mete shows you the cloud launcher for ASP.NET, we also have a cloud launcher for SQL Server. Unfortunately, it's not yet a managed service. That's coming hopefully sometime fairly soon. But you can certainly easily start up a SQL Server. We have a Visual Studio plugin, which I'll be showing you later, and which helps you do things like container engine deployments. I'll be demonstrating that. We have many .NET libraries, which are all open source on GitHub, by the way, and they let you access all of, well, not quite all yet, but working towards all of Google services like Vision and BigQuery and all these things. And then we have PowerShell commandlets, as Mete has already mentioned.
And then let me just show you the Visual Studio plugin really quickly. So I'm here in Visual Studio, and the way to install it is it's just an extension. So you would go to extensions and updates. If it pops up. Yeah, and then in here, you can just search for Google Cloud. And then the Google Cloud Tools for Visual Studio is the one. So I already have it installed. But if you don't have it, you can just double click and it will install. Once it is installed, then under Tools, you can go to Google Cloud Tools. And then there's something called Google Cloud Explorer. So this is how you would see your project from Visual Studio. So if you click here, the first thing is I'm logged in here. So that's me. And then these are all the different projects I have in Google Cloud. So I'll choose .NET Atamel as my project. And then under here, you can see your App Engine applications. So for example, in App Engine, I have one service called Default, and it has 2 versions. And this first version, version 0, is getting 100% of the traffic. I can see my virtual machines. So this is a list of my virtual machines. And you can actually right-click. So this is the NDC London one that we just created. You can right-click and open a remote desktop session or things like that. And then you can see other things as well. So you can see cloud storage, which is a place to store files. You can see Cloud SQL for your managed MySQL and Postgres instances, and Cloud PubSub, which is a publish subscribe messaging type of framework. And then if you want to deploy your application, you can basically come here, right-click, and then there's going to be another thing here, publish to Google Cloud. So you click here, and then it gives you some options. So this is a .NET Core application. So it's giving me two options, App Engine Flex or Container Engine, which is Kubernetes Engine. So I can choose wherever I want to deploy, and then you can deploy directly from Visual Studio. So this is just to give you an idea how it looks. Let's go back here. Yeah, now let's talk about .NET containers, the point of this talk. Who is using containers today? Few people. Anyone doesn't know what a container is? Don't be shy. Yeah? No? OK. So just to explain, it's basically a way to virtualize application containers. So in the past, we had virtual machines where you virtualize the whole operating system and everything that goes on top of it. So with containers, it's pretty much the same idea, except you're not virtualizing the whole operating system. You're virtualizing your application and the dependencies of your application. So this way, it's much more lightweight than virtual machines. It started with Linux processes, but now Microsoft has Windows containers as well. So you can also have Windows containers. Even though they are much larger than Linux containers, it works. So they're lightweight and isolated, so you can have multiple containers on a single operating system. They're very easy to deploy, so you can deploy a container within seconds, and they're introspectable, so you can actually get into containers as if it's a virtual machine and see what's happening. And for me, the most important part is that they're composable. So you can start with a base image that you depend on. For example, if I'm building an ASP.NET Core application, I can use the base image from Microsoft, and then I can build my image on top. And then if someone else needs my image, they can build their image on top of me, so that you can compose all these images. And each layer is cached independently, so if you have multiple images needing the same base image, you get it once on your machine, and then from then on, everyone else can use that same image as well. So that's what containers are, in case you haven't realized. In terms of how to deploy containers to Google Cloud, as I mentioned, there's two options, App Engine Flex and Kubernetes. So let's talk about App Engine Flex now. So App Engine Flex, in my mind, is the easiest way to deploy containers to Google Cloud. The idea of App Engine Flex is that you deploy your container and let Google manage it for you and scale it for you. So by default, when you deploy it, it gets deployed to 2 virtual machines, but it gets auto-scaled automatically up to 20 virtual machines, depending on the load. You get dashboards for different kinds of metrics. You get versioning, so every time you deploy your application, you get different versions of your application that I'm going to show you. Once you have your versions, you can split the traffic, so you can do A/B testing, or you can maybe do canary deployment, stuff like that. And auto-scaling, as I mentioned, is automatic. So by default, you get auto-scaling with App Engine. So let's take a look at that quickly. So I already deployed an application to App Engine, so I just want to show you how it looks like. So this is App Engine on Google Cloud. And I should probably show you here. App Engine is under, so under Compute, you see that Compute Engine is the virtual machines, and App Engine is right here. And the first thing that I want to look at is that services. So in App Engine, you can have this notion of services. These are kind of like microservices, the way you do microservices in App Engine. In this case, I only have one service. It's the default service. But you can have multiple, as many as you want. Then under versions, these are the different versions of my application that I deployed. So I have version 0 of my application, getting 100% of the traffic and running on 2 instances, on 2 virtual machines. But then I also have another version that I deployed before the talk. It's not getting any traffic yet. Since I have different versions, I can, oh, by the way, in these versions, they each get their own URL, so you can test them individually. But let's say I tested version 4, and I want it to get more traffic. So what I can do is I can come here, and I can do split traffic. And then I will add version 4. And let's say I want it to get 50% of the traffic. I can easily do this. Hit save. And with this, now the other version will also get the traffic. So if you go back here and yeah, you can see that they're each getting 50% of the traffic. And then if you really want to see the instances, you can come here under instances, and then you can see that these versions, they're just basically just running on virtual machines, and you can SSH into them if you need to, but usually you don't have to care about this. And the last thing that I want to show you is the dashboard. So under dashboard, you can choose your version, And then you can see a bunch of metrics like latency, traffic, VM traffic, CPU. I mean, this is a demo app, so I don't have any metrics here. But if you had a real app, you would see all kind of metrics in here. So you get this all by default. And all you have to do is just, from your application, you install Google Cloud SDK and just do gcloud app deploy and give a version name, and that's it. What we do is we take your application, we build a container for it in the cloud, we host it in container registry, and then we deploy it to App Engine Flex, and then you get all this for free. So it's the easiest way to run containers. So normally we build the container for you, but you can also specify a Docker file, and you can tell us what kind of container you want to run, and we'll build that container for you as well. All right, so that's App Engine Flex. The second thing, the second way of deploying containers is via Kubernetes Engine. But before we talk about Kubernetes Engine, let's now talk about our application because it's going to use Kubernetes Engine, and then we'll talk about the details of Kubernetes and how it works afterwards.
Yeah, so we're going to be demonstrating a few things in the next half hour, 40 minutes, and we're going to be using this exciting app that's described here. So I just want to talk you through how the app is architected very briefly because it's using Google Home and Kubernetes Engine and Google Assistant and Dialogflow, which are things you may or may not be aware of. So I'm just going to very quickly describe what they do. So this is a Google Home Mini. You've probably seen these. This is a conversational device. So we're going to be having conversations with this, if it's working. Hey, Google, are you there?
I'm here. What can I do for you?
Nothing quite yet. And what that's doing is that's sending the conversation to a server-side service to Google Assistant, which is what does the speech recognition, the kind of sentence parsing.
I can only help you with the first request. Okay.
I don't know what that's going to do. Now, we just need to do a quick laptop swap.
Yeah, let's just swap the laptops quickly.
And then I can show you what the dialog flow looks like, which isn't what we're concentrating on in this talk, but just so you can see kind of how the conversational side of it is configured. Plugging in wires is difficult. Right. Great, thank you. Okay, my laptop has turned off and decided not to turn back on again. No, it's working. So Dialogflow, I'll show you in a moment, is where you configure they're called intents, and they are example sentences that you want to recognize and then launch actions from. So you build up, excellent. So this is the Dialogflow web interface. So these are all my intents, and you can see things labeled BigQuery.things and Vision.things. So if we just quickly we're going to be looking at Vision. And one of the things we're going to be doing using the Vision API, or actually the Search API, is looking for pictures. So here you've got examples of the kind of phrases I might say to search for pictures. And the highlighted bit is the bit, that's a parameterized word, and the Google Assistant will fill in that parameter with whatever word I actually say instead of dogs. You can search for things that aren't dogs, like cats, for example. So that's the Dialogflow. The Dialogflow, you configure it with a webhook, as Scott was talking about this morning, and I'll just briefly show you that. There's nothing very complicated about this. You go to fulfillment, and then here there is a URL. So that's the URL that will be called every time a conversation intent is triggered. And that URL points to an application running on Google Kubernetes Engine, which we'll demonstrate in a moment. And then from Kubernetes Engine, we have some code that, based on the intents you talk, will call into the Vision API, BigQuery, and Google Search, and various other things. So just to demonstrate this works, we'll try it out. Now, a couple of things to say before we start this. First of all, I'm going to be saying those magic words that start this device. So if any of you have, well, actually you don't, because I've already said them. I was going to say, if everyone has phones with Google Assistant active, I'd like turn them off or something, otherwise you'll all be responding to the conversation. Secondly, this is what's called a test application, so it's not deployed. So the first thing I always have to do is ask Google to let me talk to my test app, and I'll literally be saying that every time we use this. And thirdly, once I start the conversation, I can't stop. So once you start the conversation, it assumes the only thing I'm talking to is it. So I can't stop and explain things as I go along. So what I'll do is I'll do some conversations, and then we can discuss them afterwards. And lastly, this is all highly experimental, and we've never done this demo before. We've never tried it in a room with anyone else apart from me in it. And being conversational, it doesn't always go quite as planned. In fact, sometimes it thinks I'm saying things that I'm sure I have never said. So with all those caveats aside, let's see what we can do. So what I'm going to do, I'll describe what I'm going to do first, and then I'll do it. So what I'm going to try and do is talk to my test application and just ask it where the server side is running. And hopefully it'll tell us. Now, one thing that isn't on this diagram is what it's also doing is it's pushing out information onto this web page here, just so we can it gives some more details about what's going on the back end. So all this is the website talking to the same server that this is being fulfilled by, and it's got a WebSocket open. It just pushes information down to here. OK, wish me luck. Hey, Google, talk to my test app.
Sure, here's the test version of my test app.
OK, ready.
What environment are you running in?
Running on Google Kubernetes Engine at location Europe West 1C on cluster named NDC Demo.
Goodbye. It worked. I'm so happy. Thank you. Thank you. So that's good news. So it knows it's running on Kubernetes. Now, I'll just quickly show you the code that's actually doing that. And I do apologize for the quality of this code. I was going to tidy it up. Yesterday, but unfortunately, the whole demo nearly fell apart yesterday, and so I was busy repairing that. Right, so we have a platform describe, and so you can see here that what I'm doing is calling this platform.instanceAsync. So this platform class is defined by one of our Google-supplied open source support libraries, and the instance async just returns an instance of the platform class that tells us where it's running. And so ignore the next few lines. So you can see here there's a switch statement looking at platform.type, and it knows about, so GAE is, can you guess? Google App Engine. GCE is Google Compute Engine, which is the VMs, and the one we had was GKE, which was Kubernetes Engine. And so you can see here, these lines here correspond exactly to what came down to the web browser we were just looking at now. And then this just say thing at the bottom. This is just how, in my code, you send things to say back to the Google home. So that's good news. And so what I'll do now is I'm just going to prove that, as Mete was saying earlier, you can deploy to Kubernetes Engine from Visual Studio using the plugin. So I'm just going to change some code, and then we'll try it out. So you may have noticed when I asked to talk to the test app, the very first thing it said was, OK, ready. So let's find the code that says that. So that's here, OK, ready. So instead, let's change that to say, how about hello NDC London? There we go. And now to deploy to Kubernetes Engine, we right-click on the project. You say publish to Google Cloud. We're deploying to Container Engine. Now, here, it gives me a list of all the clusters that I have available, which I've set up previously. So we're using the NDC demo cluster. You can specify how many replicas you need. Now, sadly and slightly embarrassingly, I have to deploy to one because the state for this application is being managed just in memory. So I have to make sure everything goes to the same instance. Obviously, this isn't productionized. And then we just say publish. And it's now going to check the state of the cluster, and in just a moment it should say, you already have an application running on this cluster with this name. Do you want to update it? And I will say, in just a moment, any second now. Come on. This is now using the internet, so it's possible the Wi-Fi here maybe is, oh, there we are. So I'm going to say update, and then we leave it. This takes about 30 seconds, between 30 and 40 seconds, if everything's working properly. And then next time we talk to this, listen out for what it says at the beginning.
OK, and in the meantime, I can explain what Kubernetes is a little bit. So, all right, so what is Kubernetes? Most of you probably know. It's a Greek word that everyone mispronounces. It's true. Actually, the right way of saying Kubernetes is Kubernetes, but I guess it came out in the US, and everyone started saying it Kubernetes, and now everyone mispronounces it. And I know this because I'm from Cyprus, and Greek is one of the languages there. So anyway, but it was great to do this talk in Greece, and everyone knew what I'm talking about because, you know. Anyway, Kubernetes, it came from an internal system at Google called Borg. So at Google, we've been using containers for a long time, for more than 10 years. And we built Borg to manage containers. So people who worked on Borg, at some point, they decided to create Kubernetes for everyone else. So the idea of Kubernetes is that you think in terms of applications and not in terms of machines anymore. Because in Kubernetes, you basically define your container and let Kubernetes manage those containers and schedule them and make sure that they are running. So it gives you all the tools basically to run containers in production. For me, the greatest thing about Kubernetes is that it runs everywhere. So it can run on your machine. It can run in Azure. It can run in Google Cloud. You can even have Kubernetes clusters spanning multiple cloud providers if you want to. So that's the great thing about it. At the very high level, this is how it looks like. So there's a master managing the cluster. And then you have nodes, the actual virtual machines, where you can schedule containers. But as a user, you don't really care. You only talk to the master, either through the API or CLI or user interface. And in this Kubernetes world, container as Kubernetes world, this is how a microservice looks like. So you start with a container. That's where your code lives. And this container lives in some kind of registry. Usually in Google Cloud, this is Google's own container registry. From there, you create what's called a pod template. So pod is the smallest unit that Kubernetes can schedule. It's either a single container, or it can be also multiple containers grouped together. And from then on, you tell Kubernetes what you want. So there's something called replication controller in Kubernetes. In this case, we are saying we want 3 replicas, so 3 copies of this pod running at all times. And replication controller will look at the nodes that you have, and it will create these pods, and it will schedule to those nodes. And it will make sure that they are running. And if one of the nodes goes down, then replication controller will detect that, and it will reschedule it to some other node. Once you have your pods running, you can label them with different kind of name-value pairs. And then with labels, you can group them. So you can group pods into what's called services. So a service in Kubernetes is kind of like a load balancer for your pods. So once you group your pods using labels in a service, then this service can be attached to an external load balancer. And then people from outside, they can hit your load balancer, go to your service, and then get your pods. So in this world, your microservice is basically a combination of your code via the container and also what Kubernetes provides, so replication controller watching your pods and service exposing your pods. And there's much more. I'm just giving you the bare minimum. But that's what Kubernetes is in microservices world. And as I mentioned, Kubernetes runs everywhere. But we have something called Google Kubernetes Engine. It's basically Kubernetes as a service. So it's a way of running Kubernetes in Google Cloud in a really easy way. So with one command, gcloud container clusters create, you can create a Kubernetes cluster that will give you a master managed by Google. And it will also give you some nodes to schedule containers. Then you can do like cluster resizing with gcloud container clusters resize. And then you can resize from 3 to 5 with this command. So it makes it really easy to get a cluster and then resize it. What else can you get? So the master is fully managed, as I mentioned. You get auto-scaling of your nodes. So you can set up auto-scaling so that the nodes can auto-scale depending on the load. You can get auto-upgrade. So if there's a new version of Kubernetes that comes in, it can be automatically upgraded if you want to. You can get auto-repair. So if your node is not in a good state, Kubernetes can detect that, and it can replace it with a new node. And you get like 99.5 SLA out of the box. And we are looking to improve this so that you have multiple masters and more SLAs going forward.
It's worth just pointing out that 99% SLA might sound not great, but that's only for the master. And if the master goes down, the cluster carries on working fine. It's just that you don't have access to the sort of management API.
Yeah, so you can't schedule new pods, but your application still runs. So it's not that big of a deal. And then even the components, so the actual nodes where you schedule containers, they're somewhat managed in the sense that everything that's logged goes to Stackdriver and it's being monitored. And you can set up error reporting. So if there's an error in your pods, you can see it in Stackdriver. So those are kind of managed as well. All right. So that's Kubernetes, and we want to now talk about the machine learning and big data part of our application. So let's just talk about those quickly. First of all, this is a graph showing the directories containing deep learning models at Google. And then you can see the graph from 2012 to to today, there's exponential. So there's a lot of deep learning happening at Google.
So is that internal to Google?
Internal to Google, yeah.
Oh, okay.
Yeah, so these are all the products, and there's probably more using deep machine learning, and you can see the trend. And this is true not just for Google, but for many big companies. So machine learning is becoming really big. And in terms of using machine learning, there's basically two ways of using machine learning, and I call it the easy way and the hard way. So the easy way is that someone figures out machine learning, and they build a model, and then they give you an API to use that machine learning, right? That's what Microsoft did show today at the demo with their Vision API. We also have many trained models with vision and speech and stuff like that. So we train it, and then we create a model, and then we give you an API to use that. And the second way of using machine learning is to actually create and serve your own machine learning. Because sometimes what's given to you, like for example with Vision API, maybe you have custom images and you want to do something custom with that. So you can't really take Vision API and use it. So in those use cases, you want to actually build your own machine learning model. For that, there's something called TensorFlow. It's an open source project, and you can take that and run it on Google Cloud and train it and use cloud machine learning to serve the model that you created. In terms of pre-built models, in Google Cloud, we have a bunch of them. Speech API, Vision API, Jobs API. There's Video Intelligence API, where you can actually pass a video, and it will tell you all the things about the video, the scenes and the labels and stuff like that. We're going to be using Vision API today. So let me just show you quickly how it looks like, and then we'll show our application. All right. So there's a demo here. And in any machine learning demo, you have to show the pictures of the cat, right? That's what happened today. So that's what we're going to do as well. So in this demo, we will basically pass in an image to Vision API, and we will look at what we get back. So we pass in this image, and then in the end, what you get is a JSON with some labels. And then this graphical tab shows us that same information in a graphical way. So what we are getting back is a bunch of labels. We are seeing that this is a cat, 99%, and this is an animal, 96%. And it's even telling us that this is a British short hair type of cat, 93%. So you get some labels. You can see the colors in the picture. So these are the colors in the picture. And then you can also see if this image is an adult image or medical image or violent image, stuff like that. I just want to show you one more example. If you pass in some text, for example, like this, then you get the same labels, but then you can also pick up the text in the picture. And then if you pass in people, we don't do face detection of people, so we don't identify people, but we can detect the expressions of people. So if we come here, and if I turn this on, you can see that we detected these people, and we can also detect their expression. So this person too, I guess it's this person right here, it's joyful. Yeah, they're pretty much all joyful, but you can basically detect people's faces and their expressions. So that's Vision API. You want to go back to? Yeah.
Yep. Oh, where is it? There it is.
And then in our application, we use Vision API. So
we do. So now we'll attempt to conversationally use the Vision API, and then we'll look at some code. Right. Hey, Google, talk to my test app.
Okay, let's get the test version of my test app.
Hello, NDC London.
Search for some pictures of London. Hang on.
Okay, let's use the Vision ML service. Found some pictures of London. What now?
Select the fourth picture.
What is the index?
4.
Picture 4 selected.
Please describe this picture.
This picture is labeled landmark, waterway, city, sky, tourist attraction, and parliament.
So what landmark is in this picture?
This picture is labeled landmark, waterway, city, sky, tourist attraction, and parliament.
What landmark is here?
I missed that.
What landmark is here?
One more time.
What should I recognize in this picture?
This picture is labeled landmark, waterway, city, sky, tourist attraction, and parliament.
Okay, go back to the pictures.
Okay, looking at all images now.
Let's select the 5th picture.
What is the index?
5.
Picture 5 selected.
Are there any landmarks in this picture?
This picture contains Big Ben.
Yeah.
Goodbye. It's very stressful running these services. Right, so just to show you using the image API there, the vision API, and it is wonderfully simple to code these things up. So ignore all the mess of this code. That's not the right one. So vision describe. So this is what got called when I asked it to describe the image. And you can see, right, I get an... I should have made that not a var, so it's clear what it is. How do you make that into a... Oh, I don't know. So we get an instance of the vision API, and just to show you how to do that, come on. Right, sorry about this. That uses this code here. So you use this image annotator client.create method, and this image annotator client is in the google.cloud.vision.v1 API package, sorry, which is available on NuGet, and the source code is all available on GitHub. And we call create. Now, normally you can do this in a parameterless fashion, so actually that literally is all the code you need. The only reason I had to put a channel in here was because I was having slight trouble with the authentication, which normally you wouldn't have. So it's normally literally just one line of code to return that. And then if we go back to the, that's auth, if we go back to the flow, and then we just call this method here. So we just call detect labels, and there's an async version and a sync version, as you'd expect. We use the image.from URI, and that allows us to give it a URL. So we don't have to pass it the actual sort of bits of the image, we just pass it a URL. You can also pass it the bits if you want. And then I've asked just for a maximum of 10 results. And then that returns this read-only list of entity annotation, which we then, so we write that to labels. We then just order that by the score, so we order by descending for the score, so we read them out in the most important order, and then we just select the description. And that's just a string of the list of labels that you heard read to you. So it's not difficult to use. And we also had the landmark API, which is very, very similar. So vision landmarks, and as you'd expect, you just call a single method, detect landmarks, in this case async. And that just returns, again, a few lines up, a read-only list of entity annotations, which is the landmarks.
Cool.
So there we go. If we whiz back to here.
Yep, so that was Vision API. And the next thing that we use in our application is something called BigQuery. So BigQuery is massively parallel processing query, blah, blah, blah. It's basically a data warehousing solution from Google that's fully managed. So behind BigQuery, there's a lot of compute power, and there's a lot of storage. What you do is you just point to the data that you care about. We ingest that, and then you just run queries against it. And the key thing here is that the queries happen really, really fast, and then they happen in a fully managed way. So you don't have to worry about clusters. You don't have to worry about the number of machines. Everything is taken care for you, basically, with BigQuery.
And you also don't have to worry about indexing at all.
Yeah, there's no indexing. So every time it does full scan, but it does it really fast that it doesn't even matter. So let me just show you a quick example of this. So this is the BigQuery console that you can get to from Google Cloud Console. And in BigQuery, you get a bunch of public data sets that you can actually play with. So these data sets, they're from Wikipedia. For example, we ingest Wikipedia, all of Wikipedia. We ingest all of GitHub, Hacker News, stuff like that. And you can, I think up to 1 terabyte, you can query per month for free, something like that.
That's true, although it's surprisingly easy to use up that 1 terabyte really, really quickly.
Yeah, if you don't write your query correctly, then you can use it. But basically, a lot of queries you can run for free. If you are curious, you can go there, and then you have these public data sets. So what I did here is that I want to see what are the most popular packages in .NET world. So what we did is we have this SQL query that does some regex matches against GitHub data that we have. And it looks for the using line, and then it picks out the packages, and then it counts them and groups them, stuff like that. A BigQuery expert in my team, Felipe Hoffa, maybe you've seen him, he helped me to write this. So don't ask me to explain what it does, but I can pass you the code if you want. So it basically does a regular expression matching all this, and then it groups them and then counts them, basically. So if you run this, you can see the query running. And I guess we had the results from before, but let's get fresh results.
Whoops.
So this is searching all of the GitHub data, basically.
So this is searching all public repos on GitHub?
Yes.
Gosh,
and
that must be quite a lot.
And then it's doing a full scan of it, and then it's doing regular expression match against that. So looking at all the code, finding the using lines, and then figuring out the actual package names, and then counting them, right? So that's done in like 30 seconds, and it processes 30 gigs of data. And then what we have, any guesses? What's the most popular package? System what? System what?
Just system.
Just system. Well, I think we were.
Oh, collections generic.
Yeah.
And that's there in the template, isn't it? So as soon as you create a class, it puts systems collections generic.
Yeah, maybe that's why. Yeah. So the system collection is generic, and then system runtime, blah blah. There's link. I remember seeing JSON package before, but maybe that was the one that I filtered system out, and then the rest was like the JSON.
Surely these are namespaces, not packages, because.
Yeah, we are looking for the namespaces. Yeah. Yes. So that's what BigQuery is, and in our application we used it. So I'll let Chris explain that. You wanna?
Yes, so there's quite a lot of these public data sets, and they're quite fun to play around with. So as Mete said, the whole Hacker News, I assume everyone here reads Hacker News, and if you don't, it's quite worth reading. So the whole, everything that's been in Hacker News is a public data set, and it's updated, I think, daily, so it's always up to date. And another interesting data set is there's a weather, or climate rather, data set giving global temperatures back to 1930 or something like that, which I'll just demonstrate. So first of all, we're going to use the Hacker News public repo.
Do you want to switch to
Yes, I do. I'll switch back to there. Okay. Hey, Google, let me talk to my test app. Let me talk to my test app.
Something went wrong. Try again in a few seconds.
Hey, Google, let me talk to my test app.
There was a glitch. Try again in a few seconds.
Oh no, there's a glitch. I wonder if we can find out what it is. And in fact, this will give us a good opportunity just to look at the Google Developer Console for the kind of Kubernetes-based items on here. So you've already seen this Developer Console, and if we go down here, here's the Compute Engine and App Engine that Mete was talking about earlier. And here we have Compute Engine, Kubernetes Engine. So here we can show all the clusters. So I've got 3 clusters under my account here. We're using this NDC demo cluster. So this gives us details of this cluster. So we can see I've got 3 machines in the cluster. It's in Europe, various other bits of information. And then if we go here, we can see the workloads that are currently running on this cluster. So I only have one job running, and it's obviously the one that's servicing this, or trying to service this, and it's called NDC Test Server. And we can see here that this is running on, so we've got just one managed pod, and you remember I deployed it just to a single replica, and this is that replica. And if we go into the pod here, and you can see this is the pod details, and it just tells us like when it was created, so that would have been today, just a few minutes ago. And it says it's running, so it tells you the container is running in the pod, so we can see the container. So it's exposed on ports 8080 and 8443, which is correct. And we can also look at the logs. So let's go and look at the logs. So there's no errors there. I wonder why this isn't working. Let me try one more time. Hey, Google, talk to my test app.
Sorry, something went wrong. Try again in a few seconds.
It's so sad. So sad. Okay, well, we might not be able to demonstrate this. I did tell you, I warned you. It was all very Very experimental. So what this was going to do was it was going to do a query into the Hacker News data set and list, you could say something like, tell me the top article on the 1st of January this year. And it would then query the data set and return that number. And it would also tell you how much data it scanned and how long it took. So because I have done this before, I can tell you that the Hacker News data set is roughly 600 megabytes in size, so much smaller than the GitHub data set. And it would take between 2 and 3 seconds to scan that. So that's suitable for interactive use. And then also I was going to demonstrate the weather data set, which is bigger. That's about 5 gigabytes. And again, it took about 3 seconds to scan. So it's pretty performant for data sets of that size. Although strictly speaking, those aren't really big data. They're in the few terabytes range. So that's not big. BigQuery can handle much larger data sets than that. And the time used to scan that data is not linear. So it's not like you go up an order of magnitude in data size and it goes up an order of magnitude in time to scan. It scales better than linear. Much better than linear, to be clear on that. Right. Oops. Right. Do you want to?
Do you want to show any of the code for this?
Oh, yes. I will just show you some code. Good idea. So this is the BigQuery. So the BigQuery Hacker News. So this is almost as simple to use as the Vision API, except of course you do have to write the correct queries. So this is the SQL. Oh, I won't. No, sorry, that's not the right one. That's the weather one. Let's go to the Hacker News one, which is here. No, it's not. Yes, here it is. Okay, so you have to write some SQL. And this looks remarkably like SQL you're familiar with because it's been designed to be very similar. And you can see there's a select. I'm selecting the title and the URL. From the table, now the table is defined just in the line above. And that's kind of like a help. That BigQuery.getTable method is sort of a helper method that means you don't have to understand the exact format to write the table name in, which isn't complicated, but it just simplifies life to be able to use that help method. We have a where clause, we have an order by clause, and we have a limit clause. And you'll see also we have a parameter here. So this works much like you'd expect parameterized SQL queries to work. And here we just create an array of our parameters, and we create a BigQuery parameter here. And then we pass that into the BigQuery.execute query async method there. And we just pass in the query and the parameters, and it does pretty much what you'd expect it to do. It runs asynchronously and returns the results into result, which is a BigQuery result type. And the BigQuery result type lets you then iterate through the rows of the result. Obviously, I'm limited it to 10, so I've only got 10 results. If you've got hundreds, thousands, tens of thousands of results, that's paginated, and you can control how much or little of those results you get back. And we handle the slight complexities of using the pagination API. It's all kind of hidden from you. Although in our API design, we always allow you to drop down to kind of the next layer down in the sort of API stack. So if you wish to directly access the sort of low-level pagination API, you can, but generally you won't need to. So there we are. That's it.
Cool.
Simple as that.
Can we switch to
Yes.
Cool, so that's BigQuery. And then the last thing, in the last 5 minutes, I want to just talk about Stackdriver quickly. So writing these apps is fun, but then you need to maintain them, right? You need to monitor them, you need to log. So for that, we have something called Stackdriver in Google Cloud. So it has logging, so it's a central place to see your logs. Monitoring, to monitor your application. Error reporting catches all the errors and then displays it in a central place where you can see all the stats about all different kinds of errors and the stack trace and stuff like that. Tracing traces the HTTP calls from your application, and then it shows you what's happening and how long each call takes. And if there's parallel calls, you can see them in parallel as well. It's very useful for debugging and seeing performance problems. And finally, debugging for me is the biggest one. In debugging, as I mentioned before, you set a breakpoint in your live code, and then when that breakpoint gets hit, it takes a snapshot of the state, and then your application continues running, right? So you can see the snapshot, you can get the data, or the stack trace that you need, but then your application keeps running. So it gives you all these tools, And the other great thing about Stackdriver is that it works against AWS and Google Cloud as well. So if you have resources running in AWS and Google, you can see them in a single place, which is nice. So that's what Stackdriver is.
And we can just quickly show you some of those Stackdriver sort of functionality. Unfortunately, I can show you most of this without having a working app over there. So first of all, I'll just show you trace. So this lets you trace calls, sort of network calls. So if we go down here to the Stackdriver section, and we go to trace, then we can overview. So this is showing overall latency for calls that we made earlier in this talk. And if we go to the trace list, if I cut this down to 1 hour, then each of these blue blobs here was one of the conversation items I had with the app, and this is the latency of each of those calls. And you'll see that some of them are up in it's in milliseconds, so 2K means 2 seconds, and some of them are higher because when we were calling into the Vision API, that can take a second or two. So if we go and look at a particular conversation, a particular trace rather, we can select this one here, which we did 15 minutes ago, and we can see that this, so we get a timeline of a call. So what this is doing is when the call first of all comes into the ASP.NET Core application that's running on Kubernetes Engine, that happens at time 0. And we responded at time 1,700 milliseconds roughly here. And so that sums up the entire sort of response to request. And then inside that, we can create extra traces that show if we've got specific actions that are happening inside that request, we can create traces that show just those requests. So from here to here, which you can see, well, all of them in fact took most of the time, this is, I'll show you some code in a moment, this is where we're dealing with the chat request. This is where we're actually answering a particular intent in the flow, and this here is the call to vision.landmarks. So you can very clearly see that it's the vision.landmarks call that is taking all the time in this request, which is expected. There's very little extra processing going on. And if I just quickly show you some code, then we can see, so we have a conversation controller. So you see this here, tracer.startSpan, and so each of those blue lines was a span. And you can create nested spans, which are the kind of, each span you saw listed are ones that are nested. So we created sort of an inner span here called flow, which is why you saw a span, here. So the third one down is called flow. Actually, you probably can't, it's a bit small. Let me just, right, so the third flow down there is called flow. So that was the span we saw in this code here. So everything within that using statement goes into that span. And you can do a lot more complex stuff than this. And unfortunately, we didn't get the BigQuery calls going here, but if we did, when you make a BigQuery call, actually it's doing quite a few lower level API calls under the hood, and you can see them all in this trace, which is nice. Okay, so that's trace. How much time do we have? 1 minute.
Can we see errors maybe?
Well, I can't make it crash because it doesn't work. But we'll
maybe
see. Maybe
already.
We'll see the errors. Yeah, yes. So we've got error reporting. Did I click? So this.
There you go.
Yes. Now,
Stack
when did this
Overflow.
happen? No, this is when I did this earlier to test it.
Okay.
So if a top-level exception escapes out of your app, or rather, within the ASP.NET Core context, if it escapes out of your controllers, if you're using MVC, then what's this called? Error reporting can catch it, and it lists them all here. So this one happened a while ago when I was testing it this morning. And so this was a Stack Overflow exception. What I had it so you could tell the app to crash, which was a beautiful thing. How many apps do you know that you can tell to crash, and they do? And you could tell it what exception you wanted it to crash with as well. And so obviously we have to crash with a Stack Overflow exception. And this is where it's reported when that happens. And it gives you, so it parses the stack trace, and it gives you, so here it happened in flow.cs line 568. And if the code for this was stored in the cloud source repository, this link would take you straight there. This code isn't there, so it won't, but we can just go and look. So if we look at flow.cs line 568, this is flow.cs, so we're just down here. And you'll see my beautiful how to crash an app function. So line 568 is indeed Stack Overflow exception. So that's it.
That's it. Yep.
So we go back to the, yep.
All right, that was it. Thanks very much.
Thank you.
And I don't think we have time for questions, but we're going to be at Google Cloud booth. So if you have any questions, just stop by there. We're going to be there for the rest of the day.
And we'll be here just in the next few minutes, so do come and talk.
Thanks.